So hi everyone, my name is Shivam Bohra. I'm a third year computer science engineering student from Dehradun. I love solving problems and I also love to teach. Welcome to our channel, Learn Competitive Programming with CodeChef. So if you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Here we post weekly problem explanations, conceptual videos on various programming paradigms, and also conduct live problem solving sessions. So before we actually get started, here's a reminder for you to hit that subscribe button if you haven't already yet. So in this video, we are going to solve the problem Make the Sum Even, which appeared in March Lunchtime 2021. The difficulty level is simple and the prerequisite is math. So the problem statement says that we have an array of size n and we have to make sure that the sum of this array is even, right? Now to satisfy this condition, we can perform this operation any number of times on any element from this array, right? So let's say I chose the ith element from this array and I'll call it as ai, right? So ai here is the ith element in this array. So what I'll do is I'll simply replace this ai by ai raised to the power maximum of 0 or ceiling function of ai divided by 2 minus 1, right? So I'll simply replace this term by this particular term. And this is to make sure that the sum of this array becomes even. And we have to find the minimum number of such operations required to make the sum of this array as even, right? For example, let's say if this is the array and we have to make the sum of this array as even. So firstly, I'll find the sum of this array. So here 1 plus 2 plus 3 is 6. So the sum is already 6. So we need not to perform any operation on this particular array. Hence, 0 operations are required to make the sum even. Hence, 0 would be the answer for this particular case. For the second case, we have 1, 2 and 4. On adding them, I'll get 1 plus 2 plus 4, which is 7, right? Hence, we have to perform an operation on this array because initially the sum is not even. So what I'll do is, I'll simply select an element from this array and I'll perform this operation on that element. So let's say I chose 2. So what I'll do is, I'll simply replace 2 by 2 raised to the power maximum of 0 comma ceiling function of 2 divided by 2 minus 1. So this is 2 raised to the power maximum of 0. The ceiling function of 2 divided by 2 is 2 divided by 2 is ceiling function of 1, which is nothing but 1. Hence it is 1 minus 1. So this is 2 raised to the power maximum of 0 comma 0, which is nothing but 2 raised to the power 0. Hence it is 1. So what I'll do is I'll simply replace this 2 by this 1, right? So I'll replace this 2 by 1. So now my sum is 1 plus 1 plus 4, which is 6. Hence now my sum has finally become even. So, and it took just one operation. So 1 would be the answer for this particular case. Now moving on to the third case, we have triple ones, right? So if I perform an operation on this one, so what I'll get is, I'll replace 1 by 1 raised to the power maximum of 0 comma 1 by 2 ceiling function of this particular thing minus 1. So this is 1 raised to the power maximum of 0 comma 1 upon 2 is 0.5 and ceiling of 0.5 is 1. So 1 minus 1, which is 0. So this is 1 raised to the power 0, which is nothing but 1. So if I perform an operation on this particular one, I'll get another 1, right? And similarly, if I perform any operation on these two ones, I'll get 1 and 1 respectively. Which means that no matter how many operations I perform on any of these numbers, I'll get the same number. right? So initially the sum is 1 plus 1 plus 1, which is 3. So it means that no matter how many operations I'll perform on any of these numbers, I'll still get 3, which means that I cannot change the sum of this array. Hence, the answer for this particular case would be -1, which means that if we are not able to make the sum of the array as even, we will simply print -1 in that case. So moving on to the approach. So firstly, as we have seen in the first example, that if the sum is 6, then in that case the sum is already even, so we need not to do anything. Hence, we will simply print 0 in that case. So if the sum is even, simply print 0. Now, before talking about the second case where the sum is odd, let us first discuss a few things. That is, let's say if we have some even numbers like 2, 4, 6, 10, 12, etc., etc., then in that case, the sum of all these numbers is always even. That is, if I take 2 common over here, then I'll get 1 plus 2 plus 3 plus 4, not 4, plus 5 plus 6, etc., etc. So you can see that we will get a natural number over here, and if I multiply a natural number by 2, then I'll always get an even number. So which means that the sum of even numbers is always even. So we can say that the sum of even numbers is always even. Now let us talk about the odd numbers. So let's say we have n odd numbers, and this time instead of writing numbers, I am writing them as 2a minus 1, 2b minus 1, and so on, right? Here a is a natural number, so 2 times a would be an even natural number, and 2 times a minus 1 would be an odd natural number or an odd number, right? So this is an odd number, this is another odd number, and so on. We have n such odd numbers over here, right? So this time what I'll do is I'll write this 2a, 2b terms and 2c terms together. So I'll get 2a plus 2b plus 2c plus 2d and dot 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 so on. And since we have n such numbers, so here we will have n terms, and similarly this is the first -1, so -1, then another -1, -1, then another -1, -1, then another -1, -1, and so on, right? And here we will have also n terms, right? Because this a single number has a single -1, and since we have n such numbers, so we will have n terms, right? So what I'll do is I'll take 2 out, so I'll get a plus b plus c plus d and so on. And here I have -1 n times, so I'll get -n, right? So this is the final equation. So we can see that this thing is always even minus n, right? So if n equals to 1, then even -1 would be odd. So there we will have odd sum, right? If n equals to 2, then even -2 is even. If n equals to 3, then in that case even -3, even minus odd is odd, right? And so on. So we can see that if number of terms are odd, as in these 3 cases where n is 1, 3 or 5, the sum is odd, right? Which means that if n is odd, then the sum is also odd. And similarly, if the n is even, like in these 2 cases, then the sum is also even, which means that if number of terms are odd, then the sum is odd, and if the number of terms are even, then the sum is even. Now let us move on to the second case. Here, firstly, I'll break the sum into two different parts, which is the sum of odd numbers plus the sum of even numbers present in the array. Now you can say that what if our array doesn't have any even number? Then in that case, the sum of even numbers would be 0. And similarly, if our array doesn't have any odd number, then in that case, the sum of odd numbers would be 0. Right? Now, we know that the sum of even numbers would always be even, because we know that the sum of even numbers is always even. And similarly, the sum of odd numbers in the array could be odd as well as even. So the sum of odd numbers in the array could be odd as well as even. Right? Now let us see how the sum of odd numbers affect our original sum of the array. Right? So I'll draw three columns over here, which is the sum of odd and sum of even and the final sum of the array. Right? So if the sum of the array or if the sum of odd numbers present in the array is even, and the sum of even numbers would always be even, then in that case the sum of the array is also even. And if the sum of odd numbers present in the array is odd and the sum of even is always even, then the sum of elements present in the array is also odd, because odd plus even is odd, right? So it means that the sum of the array is dependent upon the sum of odd numbers present in the array. So a summary of the previous slide is the sum of the array is directly dependent upon the sum of odd numbers present in the array. That is, to make the sum of the array as even, we need to have a sum of odd numbers present in the array as even, or the sum of odd numbers present in the array should be even. And to make the sum of odd numbers present in the array as even, we need to have even number of odd terms, or the number of odd terms present in the array should be even. And similarly, to make the sum of the array as odd, we need to have an odd sum for odd number of terms present in the array, or the sum of odd numbers present in the array should be odd. And similarly, the number of terms for odd numbers should also be odd, right? So indirectly, we can see that to make the sum of the array as even, the number of odd numbers present in the array should also be even. And to make the sum of the array as odd, the number of odd terms present in the array should also be odd, right? Now, our task here is to convert an odd sum into an even sum, right? And to convert an odd sum into an even sum, the number of terms or the number of odd terms should be converted from odd to even, right? That is, if earlier we had 7 odd terms, then now we should either have 6 or 8 number of odd terms, right? So our focus here is to convert the number of odd terms from odd to even. Now, for this particular case, we have 4 numbers in the given array, right? So firstly, I'll find the sum of the given array, which is 1 plus 3 plus 5 plus 2. So 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 2 is 11. So the sum of the given array is 11, which is odd. So the sum of the given array is odd. So now we are talking about this particular case. So if the sum of the given array is odd, it means that the number of odd terms present in the array must be odd. We can verify this thing. So we have 1, 2, and 3 number of odd terms present in the array, right? Now to convert the sum of the given array
from odd to even, we need to convert the number of odd terms present in the given array from odd to even, right? So here we have three number of odd terms. So either I should try and convert the number of odd terms from 3 to 2, or I should try and convert the number of odd terms from 3 to 4, right? Now to convert the number of odd terms from 3 to 2, I have to reduce an odd number, or I have to convert an odd number into an even number, right? Now let us see whether it is possible to try and reduce the number of odd terms in the given array or not. So let's say I chose 1. Now for 1, I know if I perform this particular operation, I'll end up getting 1, which we have seen in the first slide of the problem solving or of the problem statement, right? Let us try this with 3. So this is 3, and I'll convert it with 3 raised to the power maximum of 0 comma 3 by 3 ceiling function of this particular thing minus 1, right? Now we know that this is a whole number, this is also a whole number, which is because this particular thing will give us an integer, and this is also an integer, right? So I will always get a whole number in this particular case, maximum of this particular function, right? So here for this particular case, I'll get 3 raised to the power 0, which is 1. But even if I had some other odd numbers like 5, 7, or 9, for all these numbers, I'll get 5 raised to the power maximum of some whole number. Similarly, I'll get here 7 raised to the power maximum of some whole number, and here I'll get 9 raised to the power maximum of some whole number, right? Because we know that these two combined will result in a whole number. Now, the thing over here is, no matter what is the power of 5, or no matter what is the power of 5, you will always get an odd number. You can see that 5 raised to the power 1 is 5, 5 raised to the power 2 is 25, 5 raised to the power 3 is 125. And similarly, for 7, you will have 7 raised to the power 1 as 7, 7 raised to the power 2 as 49, and so on, right? So if you will raise the power of an odd number, you will always get an odd number. So this means that if you perform this particular operation on an odd number, you will always result in an odd number, or you will always get an odd number. Hence, we cannot reduce the number of odd terms from 3 to 2, or in any case, we cannot reduce the number of odd terms. So till now we have seen that we cannot convert an odd number into an even number using this particular operation. Hence, we cannot convert an odd number into an even number. So we cannot reduce the number of odd terms to even terms, or we cannot reduce the number of odd terms in the given array, right? So this particular condition is not possible. So now let us try and increase the number of odd terms in the given array. And for that, what we can do is we can convert this even number into an odd number. So I'll try to convert 2 to some other odd number, right? So I'll perform this operation on 2. So I'll rewrite 2 as 2 raised to the power maximum of 0 comma ceiling function of 2 by 2 minus 1, right? So this is 2 raised to the power maximum of 0 comma, we know that this particular thing is also is 0. We have solved it earlier, so this particular thing would result in 1, right? Because this is 2 raised to the power 0. Now we have converted this 2 to 1, and this will increase the number of odd terms from 3 to 4. Hence, it is possible to increase the number of odd terms in the given array. That is, if we have a 2 in our given array, we can simply increase the number of odd terms in the given array. Now, let us try and do the same thing with other even numbers. That is, let's say if I had 4 instead of this 2 in the given array. Let's see if it is possible with 4 or not. So what I'll do is I'll replace this 4 by 4 raised to the power maximum of 0 comma ceiling function of 4 by 2 minus 1. This time it is 4 raised to the power maximum of 0 comma 4 by 2 is nothing but 2, so it is 2 minus 1. So this is 4 raised to the power maximum of 0 comma 1, which is 1. Hence it is 4 raised to the power 1, which is 4. Now this time I couldn't convert this 4 to an odd number, right? So let us try with different even numbers. Let us try with 6. So if I convert 6 with, or if I perform this operation on 6, then I'll get 6 raised to the power maximum of 0 comma 6 by 3, which is 3 minus 1. So I'll get 66 raised to the power 2. So this is 36. So we can clearly see that for 2 I'm getting 1, for 4 I'm getting 4, for 6 I'm getting 36. So this particular pattern will always increase, right? So the only condition in which an even number gets converted to an odd number is this particular case. That is, if I have 2 in my given array, then only I can perform the given operation on this 2 and can get 1. Or this is the only case where an even number could be converted to an odd number. So the summary of our approach is, if the sum of the given array is even, simply print 0. Else, if the given array has 2 as an element, print 1. Else, simply print -1. And if you want to master data structures and algorithms, or if you want to excel at competitive programming, or if you want to do really good at coding rounds as well as coding interviews, then you should consider watching the courses conducted by CodeChef itself. Now there we have many beginner level courses like Introduction to C++, Introduction to Java, and various other beginner level courses that would be taught from the very scratch. And we have very advanced level topics like dynamic programming, trees, segment trees, graphs, trie, etc. Right? And you will be taught by really good educators like those who have cracked big tech companies, or those who have cracked big CP competitions like ICPC, INOI, etc. etc. Right? And to watch these courses, you will find a link in the description, and while registering you can use my coupon code, which is whitemagic333. So moving on to our code, firstly I'll input t, which is the number of test cases. Then I'll iterate throughout these test cases, and then I'll input n, which is the number of elements in the given array. After that, what I'll do is I'll first find the sum of the given array, and I'll check if the given array has 2 or not, or if the given array has 2 as an element or not. Here you can see that I'm not creating an array. Instead, I am storing storing the elements of the array one by one in this a variable, right? And I'm simply storing the sum of all the elements in this sum variable. And after that, I'm simply checking if the current element of the given array is 2 or not. So if it is 2, I'll simply assign the value of 1 to f. Otherwise, it would have been 0, right? This f is used to check whether the given array has 2 or not. At last, I'll check if the sum of the given array is even or not. If it is even, then we will simply print 0. If it is not even, we will check if f is 1 or not, which means that whether 2 is present or not. If 2 is present, we will simply print 1. If 2 is not present, we'll simply print -1. And that completes the whole code. Okay, so let's just submit the code. So we got the correct answer.